Right, so we're going to talk a bit about the project I took on, which was looking about predicting non-attendance in outpatient settings. And so what we've been trying to do is build up a machine learning model, and I'll take you through some of the steps. A bit about me, I guess, to start with. So I was born in the year of the ZX Sinclair, so I've been around coding for a long time, I guess. Some basic stuff there. I think one of the happiest days is when I realized you could press play and fast forward on the tape in a ZX Sinclair and load your game a bit quicker, rather than 15 minutes, would take 10 minutes. And so that inspired me into a world of computer science. And after 4 years working in labs and doing that, I decided that was not what I wanted to do and never wanted to see a computer again. Went off to be a diving instructor, see the world a bit. But then the calling came back and needed to get back to those paper clips, back to Excel and that wonderful world of data. And so came back into the NHS probably about 15 years ago. And over those years, the different turns you take in as an analyst in the NHS, I've picked up a few bits along the way. So SQL and R was quite a recent thing, and a bit of ClickSense. But I think the thing that all kind of led me to this point here, which was joining the HSMA course, which was really just inspirational in terms of its scope, in terms of using Python and some of the real kind of cool stuff that's available to us nowadays. So the situation we have with outpatients is that every month within Barts Health, we see a lot of people. We're one of the biggest trusts in the country, but we have about 18,000 appointments missed every month. That's about 12% of all outpatient appointments are not attended. And this has kind of been the case since 2020. We can see that the trend is only going upwards. Per year, this costs the trust about £30 million to provide those appointments that are not used. The estimation based on an NHS England study is there's about £1 billion worth of outpatient attendances not attended across London alone. So there's a huge problem here. It's a problem that's been around for a long time. And hopefully now we're getting to a point where we can use some of the tools to really hone in on it. So what have we done? The complication is that we have this assumption that kind of one size fits all, so that everyone is in the same. And so we have these text messages going backwards and forwards, not much else. We've got no adaptation for age, language, technical ability, or any element like that. It's all one way. The text message is limited to 255 characters, which really does take me back to the snake playing days on the Nokia. We can't concentrate on individuals. We can't identify who needs our support the most to attend their appointment. So really, the resources are spread so thinly that we can only call a very small proportion of those patients, and those patients aren't necessarily the ones that need the support to attend. So what we're trying to do is power up outpatients effectively using the features from the patient record. Barts Health has got a very, very strong data warehouse with a huge amount of data in it. I think we fed in around 360 different features in the first instance. A lot of that is kind of creating columns, but a huge amount of data, and we've got that spanning back all the way back to 2020. To hopefully get an identification of who needs our support the most. Where do we need to focus our resources to ensure that patient can attend the appointment, progress their pathway, hopefully get the treatment they deserve and want, and remove them from our waiting list. Because the flip side of this inefficiency in outpatients is that our waiting list is growing and growing and growing, and it becomes a kind of unmanageable beast. So doing all this and not creating a black box with explainable AI, XAI, which I thought was quite nice. Effectively, what we got from the back of the machine learning model are these wonderful graphs which tell us why it got to its decision. And so using a case and example here, this patient is someone who we have forecast to not attend. You can see that of the 287 other features we fed into the model, we know that it's February, so a bit more likely not to attend. They haven't got a mobile number recorded in our PAS system. They've had some long length of stays in hospital over the last 12 months. They have been cancelled. They've been cancelled a couple of times. There's quite a big gap between their booking and their appointment. And then there's all the other elements in terms of what time of the day it is, how many times have they come into the hospital by ambulance, how many times have they not attended, and what appointment type it is altogether. So all of those elements are kind of put together and fed into this model to train it. And that's effectively what we've done here. So we've given 8.2 million rows of outpatients data fed into the AI model, all the appointment histories, all the demographics, any surface interactions, whether that be in A&E, inpatients. We've got their test results, their blood results. We've got any discharge notes, or where they were discharged, if there was any delays due to social care. We've also got everything about the future booking in terms of when it was made, who it was made by. Was it an automated booking, or was it done by themselves? Who are they going to see? What resource are they going to see? What time it is? And all of that is fed into this model, which we can explain with the explainable element, but effectively it brings out all the kind of underlying themes from that data and surfaces them. And so what does it learn? So effectively, we have managed to do, well, with this model, it's a F1 score of 0.9, which is not particularly exciting, but in a way, it's pretty remarkable. I think anything other above a 0.7 is good. So 0.9 in principle could be fantastic. The F1 score, I just asked ChatGPT how to describe that, and it's effectively what it's like is if we've got a box full of toys and we're only trying to get the cars from that box of toys, a good score means that you only pick up cars, you don't pick up boats or anything like that, and when you finish the task, you picked up all of the cars. So the F1 score should be a bit more balanced to say not only are we identifying the non-attendances, but we're not over identifying them. We're not saying everyone's going to not attend or everyone's going to attend. Some of the other kind of learnings from the model, which is really useful to kind of reinforce what we kind of already know from kind of operational knowledge, is that if a patient has DNA'd or not attended previous appointments, they're much more likely to not attend the next one. So it's good to see that reinforcement coming out of that model and what it's learned. The booking date is probably an example of where AI has taken it to the next level above. We know that there's increased risk of non-attendance if the patient's appointment was booked a long time before the actual appointment. We sometimes see appointments booked about 400 days before. Now, what the model has done is that it's actually managed to segment the two categories from first and follow-up and identified that that truth is only true for follow-up appointments. So if you're having a first appointment and you booked it in a year's time, then you are still very motivated to attend. However, if you're having a follow-up in a year's time, they're much, much more likely to not attend. And that could be a multitude of reasons, but it's interesting that it's actually delineated between the two different cohorts. The pathway status as well, so the RTT, which is, have they had their initial treatment for the condition they referred to, is very a key indicator of whether they're going to attend or not. And basically saying once they've had their treatment, the likelihood of not attendance is much higher. I assume the perceived value of that appointment is much lower. So that is a key element to consider. So seeing is believing, I guess. So let's see if this works live. Let's see if we'll see it loading up. It's using that wonderful Streamlit application that so many other people have shown already. It is a fantastic way of getting a lot of the data mobilized very, very quickly. So hopefully it will work. So the use case we'll talk through is that I'm effectively a clinic manager from Whipps Cross, maybe in respiratory medicine, and I just want to go from the 30,000 bookings I have in the future. I want to identify which cohort of patients do we think are most likely to not attend and what can we kind of look into. So we'll look at respiratory medicine at Whipps Cross, and we get a list of everyone booked in with all the kind of dummy data for MRNs and mobile numbers. And what it should show us is this forecast summary. So it will show us a view of everyone that's booked in, what is the output from the model, and how do we think, what is the probability of them not attending. So we've got the confidence in it in terms of how well does the model, how confident is it that patients will attend, and what is the overall risk of that patient's non-attendance. So that is still loading in the background, so I might have to go a bit Blue Peter and say, here's one I did earlier. Effectively, so then it brings this kind of summary view of saying, like, this patient at this time, we think that maybe 37% of this clinic that's running on Sunday is not going to attend. And if hopefully when we get this one finally loaded, you'll be able to see that you could then drill down into an individual kind of date and say, actually, here's our list of patients that were booked in under respiratory who are high risk. And then we can think about whether we can contact that patient or if there's a way that we can open up communication with them to ensure that, number one, they still need that appointment. And number two, they know everything about how to get there, where it is. Oh dear, it's broken it, isn't it? There you go. Sorry, this is what I was going to show you. So it's loaded here in the background. So immediately we've gone from 30,000 down to the kind of clinic that we're most concerned about. So here we've got a Saturday clinic running, which is predicting everyone non-attending. So that's probably not going to happen, but it gives us a kind of a list to work from. So hopefully I'll be able to drill down into that Saturday, and we'll see this list of patients here where all of these have got a very high risk of DNA and we all expect them to DNA. So it might just point at a building issue. Maybe that patient isn't getting the contact they want or anything like that. So I realize I'm running out of time already, so I will plow on and go back to my thing here. So that's the demo. That's what you see. So you can go from a big data set down very, very quickly. So we're hoping to get better patient outcomes, increase staff efficiency by contacting the patients that need it. If we can move the dial even 1% on the DNA rate, if we can juice that, we can possibly release about £20,000 worth of additional income per month, or about £240,000 per year. That's just for this, just for Barts Health. We're going to pilot it further, develop it further, and keep on sharing. And now this is the bit that I guess I was as passionate as anything else about. It's, it's built by the NHS for the NHS. It's always going to be free. It's adaptable. It's collaborative. Everything's on on GitHub for you to have a look at. And I think that's probably the element that I take away most from this, and hopefully has had an impact on our organizations, this new way of working, this open source first, this collaboration, the fact that we've got people from all over the country all working together in one particular unit, I think is incredibly powerful. So it's a brilliant course for bringing that together and then really championing that open source ethos by releasing all the course materials, these wonderful books that have been developed by Sammy. It really is a fantastic thing. So I guess this is a call to arms and say, look, please do join the revolution. You know, open source your code, share it, collaborate, reuse, tailor, and you know, let's connect on GitHub. Let's go on the Python Slack. Join NHS Futures. There's a really good community there. The NHSR community is really good. That's worth joining as well. So all these wonderful places you can come and see what other people are doing and hopefully build on what has been done already to meet the needs of the future. So thank you very much for listening.
Brilliant. Thank you.
I got Chesney Hawkes in there because I thought he had to appear at least once then.
Did, Peter? Yeah, no, I was going to say, there aren't any awards, but if there were awards for best presentation, that might have automatically won it, just by having a Chesney Hawkes reference in there. So, well done. Fantastic. Thank you, Peter. Yeah, really, really fantastic story that you told there. And again, another fantastic app that I can see generating so much impact. So really looking forward to seeing, hearing more about how that progresses. So thank you very much.